Hello and welcome to Maths Learning. In this video we will learn how to use the chain rule and some of the shortcuts to differentiating some complex functions. The chain rule is a way of differentiating complex functions or expressions which are functions of functions like these. The easiest way to explain what the chain rule is if we take the symbol used for differentiation, dy by dx, and imagine that it was a fraction. In that case, this would make sense since the two terms will cancel out each other, leaving the fraction that we want. Obviously, they are not fractions, but the idea is the same. If we can rewrite the complex function with respect to another variable, usually t or u, then by differentiating it with respect to this other variable and multiplying them according to the chain rule, we can work out the differentiation much easier. First, let's consider this complex function and see what we would have to do to differentiate this without using the chain rule. We would multiply out two of the brackets, then multiply it with the third bracket. Then we would multiply it by 3. Then we would differentiate each term, which as you can imagine is a lot of work and easy to make mistakes. Before moving on to the chain rule, let's just go over again how to differentiate these terms. The first term is 192x cubed. We multiply the expression by the power and subtract 1 from the power. So 3 times 192 is 576, and we subtract 1 from the 3, giving us a power of 2. The next term is 432x squared. So we multiply 432 by the power 2, which gives 864, and we subtract 1 from the power to just leave x. The next term is 324x, which just becomes a number 324. And lastly, for the constant alone, we write nothing. Now let's see how to apply the chain rule. First, we start by writing let t equal 4x plus 3. This means that we can write y as a function of t, so y equals 3t cubed. Now dt by dx equals 4, and dy by dt equals 9t squared, which equals 9 in brackets 4x plus 3 squared when we write t back in its original form. By the chain rule, we multiply dy by dt by dt by dx. So 9 in brackets 4x plus 3 squared times 4 equals 36 in brackets 4x plus 3 squared. That is all that we have to do, and it gives us an answer that is in a similar form to the question. If we were to expand this, it would be the same as the answer given doing it without the chain rule. But I'm sure you would agree that using the chain rule is quicker. Now let's consider these next two complex functions. They look in a different form than what we have just looked at, but we can rearrange them using the rules of indices into a similar form so that we can work them out the same way. A square root is the same as raising to the power of a half, and 1 over a square root is the same as raising to the power of a minus half. So by rearranging these functions, we can use the chain rule as before. If we let t equals 4x squared plus 3, then y equals t to the power of a half, which means that dt by dx equals 8x and dy by dt equals half times 4x squared plus 3 to the power of a minus half. Then we just need to multiply them together. Once you have the answer, it's best to rewrite it in the same form as the question. So here 4x squared plus 3 raised to the power of a minus half is rewritten as 1 over the square root of 4x squared plus 3. In this question, we let t equals 4x plus 3, so y equals t to the power of minus 1. We work out dt by dx and dy by dt and multiply them together and use the rules of indices to rewrite the answer in a similar form to the question. So if you have complex functions like these, then convert them into this form with an index and perform the chain rule. Usually you will not write out your answer showing all of the steps as we have done so far, but would perform the chain rule in your head and simply write down the answer. In order to do that, you just need to remember these formulas, which will make the process so much easier. If you have a question which is a function raised to a power, then write down the power n first, then multiply it by the function raised to the power n minus 1, then multiply it by the differentiation of the function only. So here we write down first the power n, which is 4, then the function raised to the power of n minus 1, which is 3, then multiply it by the differentiation of the function, which in this case is 3x squared plus 8x. If you have a question with a constant in front of it, as in this case 3, all you need to do is put the constant at the front and multiply the rest of the question as we did before, according to the rules. Learning these rules will allow you to differentiate complex functions easily. In the other videos on differentiation, I will give you some more rules when dealing with other forms of complex functions. Hopefully you found this video helpful, and if you did, give it a thumbs up and don't forget to share, comment and subscribe. Thanks for watching, and I will see you in the next video.